Hello tubers, Mescal here. What we're looking at is the Yoke ferrite from an old CRT, and I've wound a primary and a secondary on both sides so that we've got the primaries underneath the secondary. They're both bifilar, as you'll see. The top and tail joins on both the coils. That's the tail end, and that's the other end of wire that's a 2-core type of, where is the roll? This stuff. And when I wound the primary, I just doubled up the magnet wire and then wrapped it and then cut it and then joined it across. I lost count of how many turns. I do have a photo that shows the primary turns. I was somewhere over 40 when I lost count on these ones and really couldn't be bothered. There's the specs. Ohms, half an ohm, 0.39 millihenries on the primary, 6 ohms and 12.71 millihenries on the secondary. I didn't measure both sides. There'll be some difference, but they're your ballpark figures. So just injecting a square wave across the primary and having a look at the scope. We're on 10 volts per division on the yellow. The yellow is the secondary, the primary is the blue. 5 volts per division there, so you can see about a 5 volt pulse going in. It's actually should be 3 because we're on 4.85 it says there, so that's pretty accurate. So yeah, I'll just continue climbing up the ladder on the frequencies and we'll see what happens. The square wave input. Just zoom in a bit to keep the pulses wide enough that you can see what's going on. It's just dropped off at 251 hertz. There'll be another peak coming up soon. Somewhere around 333. Keep going up. $370, $380, $400. $530. $630. Nice sinuous output for a square wave going in, and we've peaked out at 1 meg now, so that's the upper limit of this signal generator. And I'll just pop it down to sine and we'll sweep back down. See, we've got a different height on our voltage input. Alright, here we go, back down with sine wave. 900. 800, 7, 6, 4, 3, 2, down at 80 kHz. So yeah, it's got a nice wide response. Gives me, looks like there's a really broad response I can work within, like anywhere between what, 30 kHz. See where that peak starts to drop off. There. So between 30 and 200, and that's that peak. And then if we come to the next one, we can say we're what, 277. To about 400. So two nice peaks that I can work within. I reckon that'll be the go. Fall somewhere within those ranges, and there'll be good transfer and resonance of the coil set. So the plan here is to drive the signal coming out of the 30 volt panel out of the e-bike controller and go through both primaries with the positive and the negative, and then we can play with what comes off the secondaries to either do electron extraction or use it to clamp and do the mag amp or saturatable core type of modulation of the stopping how much current comes through to the cell. Thanks for watching.